Alrighty guys, in this example we're looking at inscribed angles again, and this time we're looking at the fun things that inscribed angles do with inscribed quadrilaterals, right triangles, and when we have overlapping, I call them overlappers. They're inscribed angles that share the same arcs. So first of all, let's start with inscribed quadrilaterals. Take a look at off to the left here, we'll call this example A. So we know what we're looking at. And in example A, I've got a circle with an inscribed quadrilateral WXYZ. And what we learned in our notes about inscribed quadrilaterals is that the opposite angles have a sum of 180 degrees. They're supplementary. Opposite angles are sup. So that means the opposite angles have a sum of 180 degrees. So let's take a look. Opposite angles means the ones that are not consecutive, and that would be like angle W and angle Y. They're not next to each other, they're opposite. So the measure of angle W plus the measure of angle Y should be supplementary, 180 degrees. So if angle W is 105 degrees and angle Y is unknown, well, I can subtract the 105 from 180, and then I know that angle Y must be 75 degrees. All right. We can do the same thing with angle Z and angle X. They're also opposite angles, so the measure of angle X plus the measure of angle Z should also equal 180 degrees. And I don't know the measure of angle X, but I do know that the measure of angle Z is 52 degrees. So I can subtract and find that the measure of angle X is 180 minus 52, which I think is 128 degrees. So angle X is 128 degrees. So that's one thing we can do. With these inscribed angles, we can use them inside of quadrilaterals, and there's that handy dandy property there that the opposite angles are supplementary. Cool. Up next is the right triangles. In a right triangle, we learned that if you use the diameter to inscribe a triangle, then that diameter is going to be the hypotenuse of that triangle, and it's going to be a right triangle. So if PQ is the hypotenuse, that means angle R is going to be a 90-degree angle. So we're going to use that property there, and we're going to say, hey, since angle R is 90 degrees, and they say that R is 4Z minus 10, we can set up a little equation, and we can figure out what Z is. So I had to know first that angle R was a right angle, and I knew that because PQ was the diameter. And the reason that makes sense is if PQ is the diameter, then that arc is going to be 180 degrees. So that inscribed angle, angle R, has to be half of 180, so it had to be 90, a right angle. Okay, that's why it works. Now let's go over here and figure out what Z is. 4Z minus 10 equals 90. Add 10 to both sides, and 4Z equals 100. Divide by 4, and Z equals 25. So Z is 25. Cool, so we got the right angles figured out. And last up, we have overlappers. What I mean by overlappers is this angle W here has an arc of ZY. The inscribed angle X, here you are. You might notice that it also has a arc of ZY. So they both have the same arc, which means that those two things are congruent. Those two angles and inscribed angles are going to be congruent to each other. So angle W is congruent to angle X. So that means their measures are equal. So that means that the 8a minus 9 there for angle W is going to be equal to the 7a plus 1 that's there for the angle X. And we're going to do a little bit of algebra, get all our a's on one side. So I've got a minus 9 equals 1, and then get all your numbers to the other side. And I've got a equals 1 plus 9, 10. So a equals 10, but I can't stop there. It asks for angle ZWY. Angle Z, vertex W, Y. So if I know that a equals 10, then that's going to be 8 times 10 minus 9. 8 times 10 is 80, and 80 minus 9 is 71. So that angle is 71 degrees. So those are some of the fun things you can do with inscribed angles. I hope you learned something. See ya!